is it not showing the messages? Just yeah, thank you. Good evening, good evening. Can you confirm for me if you can hear me clearly? Can you confirm if I'm audible? Can you please confirm if I'm audible enough? Can you hear me? Thank you so much. Thank you so much, Nolwantle. Let's just, we'll start at 5 past. We just want other people to join in. It's exactly 5 past. We are not worried about the numbers. It's exactly 5 past. Because I know some of you are writing tomorrow. So let's start. And today is geomorphology. Geomorphology. We are starting with the short questions. Then tomorrow we will do the 15 marks question. So today is them short questions. That is your 7 and 8 marks question. That is your multiple choice and match question. These are the questions that we are doing today. These are the questions that we are doing today under geomorphology. We are still using the same papers. That is your You're still using the same papers. That is your 2023, 2024, 2025, and the Gauteng 2023. Those are the papers that we are using. Can you hear me? Can you hear me? Just confirm. Can you hear me? Can you hear me? Just confirm if you can hear me. Thank you, Onika. Thank you, Lukwe. Thank you, Michelle. You can hear me. Thank you so much. We are starting in a minute's time. Now it's 4 past. We are starting at 5 past. We are starting at 5 past. We're starting at 5 past. Okay. All right. Let's not rush, guys. Take it easy. Let's not rush, guys. Let's not rush. Take it easy. Take it easy. We are starting in a minute's time. Let's not rush. Take it easy. Take it easy. Let's not rush. They're saying it's audible. What happened? They're saying that they can hear me. On YouTube, there's no problem. Sound. All right. So let's start. Can you hear me, guys? Let's start. Want to start now? Please do not rush, ne? Do not rush. Do not rush. Do not rush. Let's start now. So, sorry, guys. Your teacher has got flu, so here and there, you're going to hear something. Please forgive me. Your teacher has got flu. Your teacher has got flu. Please forgive me, but don't worry. You won't. It's not going to affect you. All right, sharp. Let's start now. Geomorphology. Match the concept below with the letters in the diagram. Write only the letter HH next to the numbers. 2.1.1 to 2.1.8 in the answer book. So the first thing, guys, that I usually encourage you is to try and analyze the diagram. Guys, we are not moving away from that. Is the screen featuring on the flipper side? My side flickering? It's not. Here it's fine. It's more stationary. Okay. So what we have here, guys, the first thing that should come to your mind when you look at the diagram like this, the main topic that we are looking at here is the drainage basin in SA. In South Africa, this is the topic that we start with, drainage basin in South Africa. So this is the main topic, okay, that should come to your mind. Of course, we are talking about some of these things like your river source, your river mouth, your confluence, your watershed, your water table. These are some of the concepts. So what they usually do is you can have them in form of a multiple choice. You can have the question in form of match question, or you can have a diagram where you're supposed to identify. Okay, please fix your screen. From my side, there's nothing wrong. I don't know, there's nothing wrong here. It's more stationary. It's more stationary from this side. I'm not sure, guys. Here it's more stationary. My screen is more stationary. It's not flickering. It's not flickering. Please, let's try to fix this. From my side, same say here it's flickering. I'm not sure what the problem is, but here it's more stationary, guys. From my side, it's not flickering. It's more stationary. It's flickering. Okay. I want to start, please, guys. Is it stable now? Is it stable now? On my side, it's more stable. I don't know what's happening. It's not flickering. All right, let's move. We are starting now. So what we have here, it says, okay, main concept below, make the concept below with the letters in the diagram. Write only the letters next to them. Question numbers 2.1.1 to 2.1.8 in the answer book. Okay, so I have said that this diagram, it falls under the topic that we start with when we are doing our geomorphology. That is the drainage basin in South Africa. That is the main topic. As you look at this diagram, this is drainage basin in South Africa. So you should be able now to label. Let's try to label some of these things before we even start. Okay. When you look at A, what do you think A is? What do you think A is? Oh, it's sort of flickering. I'm seeing that because I've asked my son to try to log in. He's also saying that it's flickering. Let's see. Yeah, it's kind of flickering. Yeah. I'm seeing it now. All right, sharp. Let's see. You're just trying to sort it out. I'm seeing that it's flickering. Okay, we are just trying to sort it out. Just a minute. We are just trying to sort it out from our side. We are just trying to sort it out. Please don't log out. We are just trying to sort it out from our side. Okay, how's it now? Can you confirm? Is it still flickering or is fine now? Is it still flickering or is fine? It's fine now. Okay, guys, before we start answering the question, let's move one by one. Let's look at our C. Our C. Let's just, guys, I don't want you to rush. Please, I don't want you to rush. We are not rushing. Please, let's take our time. So when you're looking at A, all right, I'm going to write the answer for A here. What do you think A is? What do you think A is? A. Before we go to the question, A can't be a watershed. Remember, this is one drainage basin, and your H there is more of your watershed. So it means this is a drainage basin, and this is another drainage basin. So A becomes an interflow. A is your interflow. High-lying areas separating two rivers in one drainage basin. Okay, two streams in one drainage basin. So a high-lying area here separating streams in one drainage basin. So your A is your interflow. Your A is your interflow, okay? Okay, sharp. How about B? How about B? What do you think? So we have said A is what? Let me just write here, interflow. That is your A, okay. Then how about B? What is B? What is B? B is the source of the river. B is the source, okay? B is the source. That is your B, all right? How about our C? Our C. What is our C? What is our C? What is our C? C is not the watershed. C is not the watershed. No, C is not the watershed. H is the watershed. C, what is C? C is the drainage basin. Drainage, let me write in small letters. Drainage basin, okay? That is our C. Sorry. How about our D? What is our D? What is our D? Confluence, that's correct. Confluence, that is our D. All right. Let's go. How about our E? What do you think our E is? What is our E? Our E can be the river mouth, of course, can be the river mouth, can be the river mouth, okay, that is our E. Can you also, that our E also, since if you look at the table, you can see there is a water table here, is passing exactly where our E is. So we can say our E can be a water table or a river mouth, because that's where the water table is passing as well. So I will take river mouth and water table. You can see this according to the key. Can you see? It's exactly. So if a learner says water table, I think I will also give them the mark there. How about our F? What is F? What is our F? What is our F? What is our F? What is our F? F, that is infiltration. Infiltration. That is our F there. Okay, infiltration, that is our F. How about our G? What is our G? Our G. What is our G? G, water table. That's correct. G, that is water table. Okay, water table. Then our H, it's high-lying area separating two drainage basins, or high-lying area separating two drainage basins or two river systems. That is your what? Your watershed. That is your watershed. Okay, that is H. All right. So guys, whenever you have got a question that covers drainage basin in South Africa, you should know the definitions. You should know how to identify them. There's nothing that is to do with river capture, please. Endina, let's remove that part, river capture. We are looking, this is a concept of drainage basin in South Africa. So that's what we are looking at now. Let's take out that river capture. Let's take out that river capture. And let's check out that river capture. This is drainage basin in South Africa. These are the concepts that we have here, what we have listed. So we have managed to identify some of these things, just to name all these drainage basin concept. All right, let's go now to our question. Let's go. Can we go to our question? Give me a thumbs up. If you want us to go to our question, can you give me a thumbs up? Can you give me a thumbs up if you want us to go to our question? Thank you so much. Thank you so much. Mozak, thank you so much. Who's this? Nolwande. Nolwande, is everything okay? I'm seeing the cry emoji there. Is everything okay? Okay, okay, okay. So I'm saying, just to conclude, under your drainage basin in South Africa, you can either get a match question, number one, or you can get a diagram where you're supposed to identify this drainage basin in essay concept. You understand? Or you can have multiple choice. So this is what we have done before we look at the question. Let's go through the question now. Let's go through the question, okay? So what is our source of the river? Source of the river. Which one shows the source of the river? What is the answer there? I want it from you now. Source of the river, we have already 2.1.1. What is the answer? Let's do this together. Let's do this together. What is the answer? 2.1.1. Come on, guys. Come on. How can it be E? Source of the river. That is your B. Guys, this is what we are talking about. This is the source of the river, B. It's not E. It's B. Usually it's an upland area. Of course, so the water flows from here going downstream. So that is your B, source of the river. Source of the river. Guys, I was identifying this with you. Why is it some people are saying something else now? This is a water table, G. This is a water table. Check your key. G is a water table. G is a water table. G is a water table. Wait, guys. This is your water table here. That's G. It's not the source. Oh, yeah. It looks like they're doing it on purpose. I see now. Because it doesn't make sense. Because everything we have identified here. We have identified everything. Okay, we have identified everything. Please, guys, if you are not interested, you can just press the log out button, please. Let's not confuse other learners. Okay, so this is, okay, where it starts. That is your B. Okay, sharp. Then which one is water table? We have already identified. Which one is water table? 2.1.2. That is your G. That's correct. Let's move on. The interfluve. Which one is the interfluve? 2.1.3. Interfluve. What did we say interfluve is here? That is your A. We have already identified that. Then next one, the drainage basin. What did we say the drainage basin is there? The drainage basin. What did we say it is? Drainage basin, C. That's correct. C. Then the river mouth. The river mouth. River mouth. River mouth, remember your E. River mouth, your E. Okay, let's move on to the next one. The watershed. What did we say is our watershed here? Watershed. What is our watershed here? Watershed. That is your H. That's correct. Watershed. That is your H. Then the next one, the confluence. What is our confluence? What is our confluence? Confluence, D. Michelle, that's correct. Confluence, that is D. That is correct. Then last one now on 2.1, the process of infiltration. What did we say about, which one did we identify as infiltration? F. You see, that is your F. That is your F. That is your F. Okay. So if you are fine with this, give me a thumbs up, then we move on to 2.2. If you are fine with this, give me a thumbs up. Then we move to 2.2. Thumbs up, guys. Let's move on to 2.2. Sharp. Thank you so much. Let's go back. All right, let's go forward. Various options are provided as possible answers to the following questions. Choose the answer, right? Only the letter A to D next to the question numbers. This is multiple choice now. Refer to the sketch below on fluvial processes. Okay, fluvial processes. Okay, that is part of your fluvial geomorphology. What can you see from this? What can you see from this diagram? Let's talk about the diagram. What can you see? What can you see from the diagram? All right, let me just say, what can you see? what can you see on the diagram? What can you see on the diagram? What can you see on the diagram? Let's start now. Remember, we don't just rush to answer. Someone is saying meander. I'm seeing a meander. Okay. Is that a longitudinal profile? I would like to differ there, guys. Is that a longitudinal profile? This is more like part of your lower course because of the landforms that we have. Remember, your meanders, you find them in the middle on the lower course. So for us to say this is a longitudinal profile, remember a longitudinal profile shows the river from the source to the mouth. So I don't think it's a longitudinal profile. I don't think it's a longitudinal profile. All right, when we look at this diagram, do you think it's showing more of a side view or a top view? When you look at this diagram, is it showing a top view or a side view? If you look at this diagram, it's more of a top. It's more of a top view. It's more of a top view, also known as what? Plan view. Okay. It's more of a top view. Okay. It's not a side view. Check the way it is. Check. You can see on top. That's where you can see the water, like here. If you look at this, you are able to see this. This you can only see if it's from the top. It's more like a vertical area photograph. If you can take a look at it, you are looking at the top. So it's more like a top view or a plan view or an area view. That's what I can see. What else can you see there? We have talked about the river mouth. We have talked about the river mouth. We have talked about maybe the lower course of the river. Lower course of the river. Lower course of the river. I can take that one as well. I can also suggest floodplain. Okay, floodplain. Okay, this is where you'll have your floodplain. So this is more of a top view. I can't take this as obviously lower course of the river. We are likely to have laminar flow. We are likely to have laminar flow there. There is gentle gradient. There is also gentle gradient. There is also gentle gradient. There is deposition is dominant. Deposition is dominant. Is dominant. What else can we talk about? This is not the upper course, guys. Check, there's a meander. It's close to the river mouth, so it's not the upper course. Okay, sharp. Okay, it's not the upper course. Of course, lateral erosion. It can also be lateral erosion. Lateral erosion. Lateral erosion. Please, let's take out river rejuvenation here. Take it out. This is the lower course of the river. Lower course of the river. Lateral is not that dominant, but it's there. Transportation is more in the middle course. Okay. So what you can see, a meander, top view, plan view, river mouth, it's the lower course. Can you see the Oxford Lake there? There is a meander. There is a meander, but we don't see an Oxford Lake. Let's tell the truth. It's gentle. It's gentle slope. The slope is gentle. This is the lower course. Remember, the river has lost most of its energy, so it starts to deposit. So it's gentle. Okay. Can you see a braided stream, guys? Let's talk about what we can see. Of course, I know you find it there in the lower course as well, but we are just talking about what we can see there. All right. Okay, sharp. Let's try to be simple, guys. Let's try to be simple. Sea level, of course, I can take that one. All right, meander is a top view or a plan view. Why am I why am I rejecting the longitudinal profile? Because longitudinal profile is supposed to show you from the source to the mouth. This is more of part of middle, lower course. So it's not showing a longitudinal profile. Yes, I'm also on YouTube. I'm also on YouTube. You can check also. I'm also live on YouTube now. All right. Are you fine with what we have said now? Are you fine with what we have said now? In as far as this diagram is concerned, so that we can start answering the question. Are you fine? Are you fine? Are you fine? Are you fine? Someone is asking, is it graded or ungraded? Are you fine? All right, guys, I don't want us to Mix, all right, okay, sharp. Let's look now at the question. Let's look at the question. All right, sharp. The sketch, what is it illustrating? We have already said something that is to do with this. What is it showing here, this sketch? What is the answer for 2.2.1? What is the answer? It's a plan view. Okay, it's a plan view. It's not a cross section, guys. It's a plan view. Our answer there is B. It's not a cross section. A cross section is source from side to side. Your transfer is cross section from bank to bank. That's not showing that. This is more from the top. It's not longitudinal profile. Why am I saying that? Because it's not showing the river from the source to the mouth. Oblique, it just means it's a view from an angle. Oblique, it simply means at an angle. That's what it means. It means at an angle. Okay, plan view. If you look at this diagram, someone is asking why is it plan view? It's a top view. You see it from the top. Look at the river. Look at this river. You can see the top part. That's why you're able to see the water that is in the river. If you can look at it, that's what makes it a plan view, which is a top view. It's a top view. Okay, thank you. Are we all fine with 2.2.1? So we have said that it can't be a longitudinal profile because it's not showing from the source to the mouth. Okay, sharp. Are we all fine? Let's move on. So it's a plan view. Yes, there's someone who asked about the oblique view. Are you fine now? Oblique simply means at an angle. Oblique, it means it at an angle. That's what oblique means. Oblique means at an angle. Okay, sharp. Let's move on to the second one. The fluvial landform shown on the sketch is, what fluvial landform are we seeing here? What fluvial landform or feature are we seeing? We are seeing the twisting and turning of the river, which is what? A meander. This is the meander that we are seeing here. So our answer there is what? A meander. That is the fluvial. That is C. Okay. Then the next one. This fluvial landform feature occurs mainly in the, okay, where does it occur mainly? Mainly. It's mainly in the lower course. You can find it in the middle course as well, but it's mainly in the lower course, according to what you are seeing on the diagram. It's mainly the part which says, this part, guys, I know you find both in them. This part is what should guide you. It's mainly, I understand you get it both in the middle and lower course, but it's mainly in the what? Lower course. Okay. Are you following? If there was not that way saying mainly, I was going to look at A and B, A and C to be the answer. A and C, that is the middle and the lower course. You find it in both. But since our diagram is showing more of the lower course, that's what makes C to be the correct answer. But in meander, you find it in both the lower and the middle course. Are we together, guys? Are you following? I hope I'm not confusing you. Are you following? Okay, if we agree, let's move on to 2.4. So what qualifies C is the part mainly and what we have on the diagram. That's why we have said C. But a meander, you find it both in the middle and the lower course. Are we together? Give me a thumbs up. Okay, sharp. If we are together, what I don't want is only to confuse you. Okay? The dominant geomorphological process taking place in the course of the river. All right, let's do it this way. All right, let's do it this way, guys. Before we answer this question, in the upper course, what happens in the upper course? What is the dominant process? Upper course, we have got what? Vertical erosion, isn't it? Vertical erosion. Then in the middle course, what do we have? We have lateral, isn't it? Erosion. Then in the lower course, what do we have? We have more of deposition. Okay. All right. Are you following, guys? So the dominant process in all the courses of the river, upper course vertical erosion, middle course lateral erosion, lower course deposition. So what is the answer now for 2.2.4? What is the answer? What is the answer? The answer, it means our answer here is what? Is A. Okay. Our answer here is what? Is A. Are you following? I was trying to explain here so that you understand. So in the upper course, the river, the gradient is steep. Okay, which means there is higher velocity, or the water is moving at a faster speed, so there is more downward erosion, which is vertical erosion in the upper course. In the middle course, there is more transportation, which means there is lateral erosion, which is side to side erosion. Okay, that is lateral in the middle course. In the lower course, now gentle gradient, the river has lost most of its energy, so it starts to drop or deposit some sediment. So there's deposition. Are you fine with 2.2.4 so that we can move forward? Are you fine with 2.2.4? Are you fine with 2.2.4? Okay, sharp. Let's move on to the next one. All right. So here, the main concept concept is what? River rejuvenation. River rejuvenation. Let's explore the concept. What is river rejuvenation? Let's start now. Let's try look at the diagram. I know it's saying rejuvenated river, but let's just talk about what do you think rejuvenation is? What is rejuvenation? What is river rejuvenation? What is river rejuvenation? Okay. Rejuvenation. What is river rejuvenation? All right, that's what we want to explore now. Let's go through it. What is river rejuvenation? When a river begins to regains its erosive power, what does it do? And it does not end there. When a river regains its erosive power, then it starts to erode vertically. So you cannot define river rejuvenation by just by saying when a river becomes more energetic. But what does it do when it gains its power? It starts to erode vertically. That's what defines river rejuvenation. When river regain energy and start to erode vertically. Okay? When a river regains its energy and starts to erode vertically. Okay. So what defines our river rejuvenation? In short, we are saying what defines our river rejuvenation in short is the river becomes more energetic. And what does it do when it becomes more energetic? It starts to erode vertically. There is more downward erosion. So you cannot define your river rejuvenation without mentioning river regains its energy and start to erode vertically. So those two things define your river rejuvenation. Okay, those two things defines your river rejuvenation. Okay, what are some of the causes of river rejuvenation? What are some of the causes of river rejuvenation? Let's talk. What are some of the causes of river rejuvenation? What gives river okay, heavy rainfall? Okay, heavy rainfall, that's correct. Which means heavy rainfall, it increases the velocity of the river. Okay, high velocity. All right, I'll say high velocity. Okay, high velocity. What else? Drop in sea level. Drop in sea level. What else? Tectonic uplift. Tectonic uplift. Or isostatic uplift. Okay, what else? What else? We are not talking about the resulting landforms, please. Mole Mabilo, you are not talking about the resulting landforms. What else causes river capture? That's correct, river capture. Okay, what else causes river capture? Okay, what else causes? We are looking at the causes of river rejuvenation. We've said you have rainfall, high velocity, drop in sea level, tectonic uplift or tectonic isostatic uplift, river capture. What else? Change in weather. Let's just equate it with heavy rainfall. What else? More volume in terms of high velocity. So we are saying when more tributaries join the main river, more tributaries joining the main river, okay. What else? What else? A drop in sea level. The correct answer there, a drop in sea level. Drop in sea level because it creates a nick point. That's how the velocity or the energy of the river increases. A drop, not a rise, a drop in sea level. It creates a nick point when the sea level drops. Okay, the sea level, that's the lowest that the river can erode. So when it drops, so it means it creates a nick point. Then it means velocity increases, the river becomes more energetic. Okay, so what else? More tributaries joining. What else? When a dam bursts, when a dam bursts on the downstream, okay. It can also result, okay, what else? Guys, frost pocket, like seriously? Geomorphology, frost pocket? Come on, guys, come on, guys, come on, guys. Please, let's avoid just sending some concepts that are not related to the content that we are doing, guys. We don't want learners to be confused, guys. I'm not doing this to confuse you guys. Please, 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 please. We are about to write and we are talking about geomorphology. Someone is saying frost pocket. Guys, don't do that. Don't do that. Don't do that. You are going to end up confusing other learners here. Okay, so I think in general, what are some of the resultant landforms? Resultant landforms that are formed as a result of river rejuvenation. What are some of the resultant landforms? What are some of the resultant landforms that are formed? That's where now we can talk about incised meanders. Incised meanders. We can talk about river terraces. Okay. River terraces. Okay. We can talk about nick points. Okay. Nick points. What else can we talk about? Valley in a valley. Valley in a valley. Valley in a valley. What else can we talk about? What else can we talk about? Valley in a valley. What else can we talk about? Resultant landform. Terrace rivers. River terraces. Okay, I've already written that one. Okay. Okay. So now that you understand the concept, okay? Now that you understand the concept according to what we have laid down, I'm 100% sure that you understand the concept now. Incised, not is not entrenched. Incised is incised meanders, which means to incise is to cut deep. To incise is to cut deep. They are called incised meanders, which means to incise is to cut deep. Remember, when there is more downward erosion, that's how it is incised. Because when the river gets more energy, it cuts deep. That's your incised meanders. Okay, thank you. Now that we understand the concept, guys, now that we understand the concept, is there anyone who can say, I still struggle with the river rejuvenation before we start answering the question, or you are fine? Anyone who can say, I still struggle with the concept, are you all fine now? We have defined what it is. We have looked at what causes it. We have looked also at the resultant landforms. Okay. All right. Don't worry. We'll get to that. We will get to understand the terraces. Don't worry. The river terraces, what you are seeing here, which means at some point, the river valley will be up to be up here. But as there is more energy and vertical erosion taking place, you can see now it has moved. These are your terraces here. These are your river terraces here. You can see this part. This part, see, as it drop, these are your river terraces here. These are your terraces. These are your terraces starting from the top. That's basically what this is all about. Okay, Bonolo, what is confusing you? Because here we have tried to lay it out. That's why I said, let's grasp the concept first, then we can apply. when we are answering the question. Bonolo, what is confusing you? Can you tell me what is confusing you so that I can know how to help? Because I don't want anyone to be left behind. Bonolo, can you tell me what is confusing you so that I know how to help? Okay, what is it that is really confusing you? You still struggle. What is confusing you? We have said river rejuvenation, when a river regains its energy and it starts to erode vertically. So that's how you define that concept. River rejuvenation. The river has got more energy. The moment it becomes more energetic, which means there is increased vertical erosion. That's basically what river rejuvenation is. So we are saying when you look at the causes, so what causes the river now to becoming more energetic so that it starts eroding vertically? That's when we talked about heavy rainfall. It means now when we receive rainfall, it means now there's going to be, assuming that there's going to be more surface runoff, it means there's going to be more water in the river, which increases the velocity of the water, that is the speed at which it is flowing. So when it's flowing very fast, that's what makes it to be more energetic and it starts to erode vertically. That is river rejuvenation. Higher velocity, we are looking at the speed at which the water is moving. It's very fast. So that's what makes it to be more erosive. And it also starts to erode vertically. That's what we mean when we talk about here. We have talked about heavy rainfall. Here, we have talked about high velocity. The drop in sea level. Think about an ungraded profile where you've got your waterfalls, you've got your rapids. It's more like a turbulent flow. So there, in terms of gradient, it's more steeper, which means the water is flowing very fast. That's what makes it to be erosive. Hence, it also results in river rejuvenation. River capture. We are saying now this is when a more energetic river captures the headwaters of a less energetic river. There is a question that covers river capture. We're going to cover it in detail. So which means when a more energetic river captures the headwaters, which means the volume of the water in that river, the capture river, that has captured the less energetic, there's going to be more volume, which means the river now has got more energy. It starts to erode as well. When we are saying more tributaries joining the main river, we are saying, like for example, let's say there is our river. Let's say there is our river here. Then we have got this tributary, we have got this tributary, we have got this tributary, we have got this tributary. There is another one here, there is another one there. All these small streams, they are adding water to this main stream, here. They are adding water to this main stream that is here. This is the main stream, which means the volume of this stream is going to increase because of these tributaries or streams that are adding water to it. That's how it becomes more energetic and start to erode vertically. So that's what we mean when I say more streams joining the main river. So when a dam bursts, obviously the dam is full, then they try also to ease the pressure on the dam. Obviously the water is going to go through the spillway on the other side, downstream, which means downstream there's going to be river rejuvenation. Why? Because there's going to be more water that is flowing as we try to relieve the pressure on the dam. So downstream is going to be more water. That's basically what we are talking about. Okay. Then what else? Then we also have resultant landforms. What is formed? Incised meanders. Obviously, we are talking about to incise is to cut deep. All right. So it means now when the river has got more energy, it starts to, there's more vertical erosion. That's how it incises. It cuts deep, resulting in river rejuvenation. When you talk about river terraces, you can look at this diagram. Can you see? At some point, it used to be at this higher level. But because of vertical erosion, what happens? There was downward erosion, which means it's now leaving step-like features. These step-like features that you have, these are your river terraces. These are your river terraces. Okay. Then nick points, these are the change in gradient along the river. That is what? That's your nick points. Okay, where there's a change in gradient. Okay, valley in a valley, like what we have, this is a valley. So if there's going to be more vertical erosion, it's going to create another valley. That's valley in a valley. Okay. Are you fine now? We want to move on to 2.2.5. If it's fine now, can you give me a thumbs up? I think Bonolo, you're fine now. I want confirmation from Bonolo. Bonolo, are you fine now? Bonolo, can you confirm for me? Thank you. All right, guys. A cause of river rejuvenation is shown in the sketch. What is happening here, guys? What is the correct answer? Guys, I have explained this, guys. I expect you to give me the correct answer. What is the answer there? What is the correct answer? The correct answer is C. A drop in sea level. When there is a drop in sea level, which means neck points are created, it means now the volume and the velocity increases energy, then we have got river rejuvenation. It's not a rise in sea level, it's a drop in sea level. As the sea level drops, we have got more neck points. The velocity of the river increases. River becomes more energetic, then we have got more vertical erosion. 2.2.5, the answer is C. Are we all fine? Give me a thumbs up if we all understand. Are we together? Thumbs up if it's fine with you guys. There's no one querying this answer. Are we together? The answer there is C. Are we together, guys? Give me a thumbs up. Thank you, thank you, thank you, thank you, Nolwande. Thank you. Let's move on. 2.2.6. The landforms or features visible on the sketch due to river rejuvenation. What can you see on the sketch? What can you see on the sketch? Okay. What can you see on this sketch? What can you see? I've talked about these are what? Can you see? You can see the paired terraces. I can see the paired terraces there. Paired terraces. Okay. What else can you see? What else can you see? I can see. What can you see? What else can you see? Valley in a valley. A valley in a valley. That's something that you can also see. Valley in a valley. Page terraces. Remember? Okay. Let's go back now. What will be the answer here? Visible on the sketch. So it means we have got this. We have got this. Then we have got this one as well, which is 3 in Roman numerals. Which is 3 in Roman numerals. That is 1, 2, 3. Okay. This is 1, 2, 3. So it means our answer is what? C. Our answer is C. Are we together? Okay, someone is asking Nolwande, okay, let's go back to the diagram. When you look at this diagram, Nolwande, when you look at this diagram, it's fine. You don't have to apologize. We are here to learn. We are saying now, when rejuvenation takes place, the river gains more energy, then it starts to erode vertically. So at some point, our river used to be up at this level. But because as it gains energy, it starts to erode vertically. So this is what resulted in these step-like features. These are the river terraces. These are step-like features that are formed as a result of river rejuvenation. This is what we call the paired terraces. So it means at some point it was here, then vertical erosion takes place, river gets more energy, it rolls down again until it's where it is now. So these are the step-like features that are formed as a result of river rejuvenation. That is your paired terraces. So these are the paired terraces here. What you can see here, from here, it goes down, step-like features, this one as well, this one as well, this one as well. Is it clear now, Nolwande? Give me a thumbs up if it's clear now. Is it clear? Nolwande, I'm waiting for your confirmation. Please don't apologize. Step-like features that are formed as a result of river rejuvenation. So we are saying it starts off like this. Then what happens is the river gains more energy. It starts to erode vertically, which means at some point the valley was up, but due to continued rejuvenation, it continues to erode vertically. Then it creates these step-like features. That's what you can see here. That is your paired terraces. That is your paired terraces. Okay. Is it fine now? Is it fine now? All right, sharp. Thank you. Let's move on. Let's move on. All right. All right. This one now, the longitudinal profile. The longitudinal profile of the river after rejuvenation would be like, let's choose now. What would be the right diagram here that shows the longitudinal profile of the river after rejuvenation? What do you think will be the correct diagram there of the longitudinal profile after rejuvenation? What do you think, which one do you think will be the right diagram? I also agree with D. Why are we saying D? D is correct. Why are we saying it's D? Because the river has regained its energy, it starts to erode vertically, which means you are supposed to see a lot of nick points. You are supposed to see a lot of nick points. Nick points, or you are supposed to see an ungraded profile. Okay, exactly. It's nick point, not knit. Nick, K-N-I-C-K. Nick point, not knit point, nick point. So because of this, these are the nick points. So it is because the river now has become more erosive. It has gained more energy. That's why it now having an ungraded profile. So that's why we are saying our answer is D, it's correct. This is more of a graded profile. It shows you that the rate of deposition and erosion is in equilibrium. Okay, so this is the correct one. That is D. All right, thank you, thank you. All right, so we are done with the 2023 paper. Let's move on now to 2024. Can we move on to the next paper? Remember, today is short questions. Tomorrow is 15 marks question. Can we move on to the next one? Give me a thumbs up. Give me a thumbs up. Give me a thumbs up. Give me a thumbs up so that we can move on to the next one. Thank you, thank you, thank you, thank you, thank you, thank you. So we are moving on to 2024 now. We have got 4 papers, okay? Let's look at this. Is it visible enough or you want me to zoom it? Okay, sharp. Let's start now, right away. The first one, remember, drainage basin in South Africa, those concepts now, you are seeing them. There are certain concepts, I'll talk about this as we progress, okay? An area, let's say, area drained by river and these tributaries, what do we call it? From the options given, what is the answer? What is the answer? Motsaki, that's correct. That is your Z, isn't it? That is your Z, that's correct. Then the next one, promotes rapid rise in water table. What promotes rapid rise in water table from the options given? What promotes? 2.1.2, 2.1.2. Are you sure, guys? How will steep gradient promotes erase the? What is the water table? What is the water table? Let's try to. What is the water table, guys? It's the highest permanent level of water underground. That is your water table. So steep slope, it encourages more steep slope, steep gradient, it encourages more surface runoff. So there's no way steep gradient can increase water table. Steep gradient, it encourages more surface runoff. So when it's gentle gradient, which means there's water has got enough time to infiltrate. So your answer there is why. Here is why. Because gentle gradient, it allows water to settle. Then it starts to infiltrate. But when the gradient is steep, as soon as it rains, then we have what? Surface runoff. There is no infiltration that is taking place. So it does not rise the water table. It does not increase the water table. So the correct answer there is what? Your correct answer there is why. Are you okay, guys? Are you okay? If you are fine with this, give me a thumbs up. Give me a thumbs up. Steep gradient, it encourages surface runoff. Okay? Gentle gradient, it encourages more infiltration. So it means where we have got more infiltration, that's how you can raise the water table, which is the level of water underground. That is your water table. Are we together, guys? So the answer for 2.1.2 is why. Are we together? If we are together, give me a thumbs up. Give me a thumbs up. Give me a thumbs up. Anyone confused with this? Is there anyone confused with 2.1.2? I don't think there is anyone confused. Okay, sharp. Let's move on to the next one. The upper level of groundwater. What do we call the upper level of groundwater? I was talking about it now. What we call the upper level of groundwater? 2.1.3. Come on, guys. That is your what? Your Y. That is your water table. That is your water table. Why? water table. Through flow is more like your base flow. The water that is flowing underground and it flows towards the streams. It adds water to the stream. Okay, that is your through flow. That is the underground flow of water. That is your through flow. It's already underground. It flows and it supplies the streams. Okay, that is your through flow. Then 2.1.4, seepage of water into the ground. What is it? 2.1.4. What is the answer? 2.1.4. That is your Y. That's correct. That is your Y, which is infiltration. Infiltration. Then causes reduction in surface runoff. What causes reduction in surface runoff from the options given? 2.1.5. What causes reduction in surface runoff? It can't be Y, guys. Impermeable rocks, which means they do not allow water to pass through them, which means they increase surface runoff. Impermeable rocks, what they do is they increase surface runoff because they do not allow water to pass through them. They are not permeable, does not allow water to pass through them. They are not porous. So impermeable rocks increase surface runoff. So your answer is dense vegetation. Just picture this. If you have got dense vegetation when we receive rainfall, which means when the raindrops come, they are intercepted by the tree leaves. So it means now the pressure of the raindrops is reduced so that when it gets to the ground, it starts to infiltrate. So your answer there is Z. That is your dense vegetation. That is your dense vegetation. This is more of a concept of your drainage density. Drainage density, what encourages more drainage density and what encourages less drainage density. Okay, that's what we are talking about. 2.1.5, is there anyone confused? If you want me to explain further, I don't mind. 2.1.5, are we together? 2.1.5, we are saying impermeable rocks increase more surface runoff. Okay, impermeable rocks, they do not allow water to pass through them. Playo, okay? Impermeable, this one, okay? What it does is it increases, let me just try to, okay? Increase runoff, okay? It increases runoff. That is impermeable. It increases runoff. But your dense vegetation now, okay? So we are saying impermeable does not allow water to pass through it. So which means if it does not allow water to pass through, which means there is no infiltration. Where the rock is impermeable, okay, there is no infiltration. There is more surface runoff. You understand? But where we have got dense vegetation now, we are saying now the pressure of the raindrops when it rains is intercepted by the leaves. So when the water gets to the ground now, there isn't much pressure. It's not going to close the pore spaces. It will start to infiltrate. So in this instance now, the two, Z, dense vegetation, it encourages more, it reduces more surface runoff. That's basically what we are saying. Impermeable rocks it increases surface runoff. This increases runoff, impermeable rocks. But dense vegetation, it reduces surface runoff because it encourages more of infiltration. Is it clear now? Frielo, Molemabilo, and Wami, is it clear now? Give me a thumbs up if it's clear now. Think about the concept of drainage density. Okay, Frielo said yes. Wami and Mole Mabilo, can you confirm, please? Thank you. Is it clear now? I want to move on to the next one if it's clear. I want the other two to confirm because they said that they do not understand. Wami is fine as well. And I'm waiting for Mole. Thank you so much. So let's move on to 2.1.6. It says the confluence is located. Okay. The confluence, what is a confluence? What is a confluence? Of course, the answer is Z. But what is a confluence? What is a confluence? The answer is Z is fine. Okay. What is a confluence? Where two or more streams meet. Okay, like this. All right. We have got this. Then we have got this. So where these two meet now, All right, of course, we can say maybe it's going to go like this. So this is our confluence where these two are meeting here. That is our confluence. Okay, sharp. Let's move on. Next one. High-lying area separating two tributaries in the same. All right. I want you to take note, guys. You should be very attentive to detail. You should be very attentive to detail. You say high-lying area separating two tributaries in the same river system. Same river system. Which means here we are talking about what? Same drainage basin. Same, okay. Drainage basin. What will be your answer here? Here there are two river systems. This is river system 1 and this is river system 2. So that makes this one to be what? A watershed. This one becomes a watershed. Here there is one river system, two tributaries. This becomes what? An interflow. Okay. Are you following, guys? So our answer here in the same river system, which means our answer is what? Is Z. That is our answer. Our answer is Z. High-lying area separating two tributaries in the same river system. Our answer is Z. This is the same river system. Here there are two river systems, 1 and 2. Drainage basin 1, drainage basin 2. High-lying area is a watershed. Then here is the same drainage basin. Two separate tributaries are separated by this, which is your interflow. Here, that is your interflow. That is your what? Interflow. Okay, Mozart, I want you to look at this. Can you read this here? It's where it's read two tributaries in the same river system, which means same drainage basin. We have got one drainage basin. So the tributaries within that drainage basin, the high-lying area that separates the tributaries within that one drainage basin, that is an interflow. But when we have got two river systems, system 1 and system 2, 1 and 2, this is a watershed. And this is your interflow. Okay. Is it clear now, guys? Is it clear? Is it clear, guys? Is it clear? Is it clear? I don't mind explaining until you understand it, okay? Please explain. Say, when a tributary joins a mainstream confluence, am I correct? When two, not when it joins, where they meet, two tributaries meet, that's a confluence. These two, 1 and 2, where they meet here, that is a confluence, okay? Where they meet, that's a confluence. Not just joining, but where they meet. Of course, part of joining, but where they meet, two streams meet, that's your confluence. Are we fine with 2.1.7? 2.1.7, we are saying we have got here, let me just say, river system 1. Then we have river system 2. Here we have got one river system. Are you fine now, guys? No. It's not like you can't oppose, guys. If it's wrong, it's wrong. It's your right. It's right, guys. If I said something wrong, you have to say this is wrong. Why are you saying that this is the correct answer? That's how we do it here, guys. There's nothing like you can't oppose the teacher. If you see something is wrong, please don't just keep quiet. Endinako, it's not like that. Please, guys, if you see something is wrong, please, you can ask, you can argue. It's not a problem with me. It's not a problem with me. I'm not the messiah of the subject. If you feel like I've made a mistake on something, ask, and I will explain until you understand. We agree to disagree and disagree to agree. So here, guys, we want that that criticism. I want it here. It's welcome. It's welcome. Don't be scared to ask. 2.1.7, the answer is Z. This is one river system here at Z. The question is saying two tributaries in the same. Two tributaries in the same river system. So do we all understand 2.1.7? Do we all understand 2.1.7? All right, wait, I'll show you. Are we together, guys? Please don't be scared to ask. Don't be scared. Even if I said something, you see that it's wrong. It's your right to ask. Please. Please, please, I want you to participate. If I say something and you feel it's wrong, ask. I welcome all criticism, guys. Please, don't be scared to ask. Don't be scared to ask. Are we fine with 2.1.7? Give me a thumbs up. Is this question clear now? So this is a river system 1, river system 2. This one is saying same river system. So the answer is Z here. Okay, sharp. So let's go to the top. Okay, this is 2.1.1. Someone was saying, show me 2.1.1. There it is. Okay, sharp. Let's move on to 2.2. 2.2 now. Okay, we are on 2.2. Please, guys, don't be scared to ask. Ask any question. Ask any question. Even if I say something you feel that is wrong, it's your right. Ask me. Don't be scared to ask. Please, 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 don't be scared to ask. We are here to learn. We learn from each other. The same way you're learning from me, I'm also learning from you. So don't be scared to ask any question. All right, let's read now. Various options are provided as possible answers to the following questions on fluvial processes, okay? On fluvial processes and landforms, features. All right, so we are going to climate and weather. We are done. Climate and weather. We are done. We covered that on Monday and Tuesday. We are done with climate and weather. All right. So when you look at this diagram, let's analyze this diagram. What comes to your mind? What can you see on this diagram? What can you see? I'm seeing a V-shaped valley. V-shaped valley. Which suggests that is the upper course, isn't it? Upper course, okay, which suggests that is the upper course. I'm also seeing what? I'm also seeing more of vertical erosion, okay, erosion. Not waterfall as such, guys. What can we see here? This is a deep valley, which suggests that it's in the upper course. Ne? Of course, I know you are looking at this and you are equating this to a waterfall. I know someone is looking at this. All right, I know someone is looking at this maybe. Let me just try to, okay. Let's be simple, guys. V-shaped valley, upper course. I'm also seeing vertical erosion. Let's try to be simple. Of course, the way here that is kind of flowing, of course, you can suggest that as well. But let's think more V-shaped valley, upper course. What kind of profile is this? What kind of profile is this? It's a transverse. It's a transverse. We called it a transverse or a cross profile. Okay? Transverse or cross profile. Okay, that's what we can see here. Are we fine with this, guys? That is a V-shaped valley in the upper course, more vertical erosion, transverse or cross profile, which means bank to bank. Okay, sharp, side view. Let's go now to our question. The first question now reads, is responsible for the shape of the river valley below? What is responsible for the shape of the river valley below? So, it's going to be too much now. What is responsible for the shape of the river valley below? What is responsible? What is responsible? That is your vertical erosion. That's correct. That is your what? Vertical erosion. The correct answer there is what? Is D. That is correct. Okay, are we okay? Let's move on. The next one reads, forms at the base of the waterfall? What forms at the base of the waterfall? What forms at the base of the waterfall? We are going to have something like this, okay? This is more of your, okay, resistant rock. Okay, what will be the answer? This one is what we are referring to. That is your plunge pool. That is your plunge pool. Your answer there is D. That is your plunge pool. That's what forms at the base of the waterfall. That is your plunge pool. A gorge is more like that deep valley. That's a gorge. So your answer there is plunge pool, which is D. That is your plunge pool. Okay, this will be your resistant rock as it is retreating upstream, of course. So this is a plunge pool that is at the base of the waterfall. Are we fine with 2.2.2? Are we fine so that we can move on? Give me a thumbs up. Vuelo and Nako, are you fine with 2.2.2? The correct answer there is D. Thank you. The correct answer is D. That is a plunge pool. All right, let's move on. The landform, what can you see here? Let's talk about what you can see here. What can you see here? I'm seeing number one. I can look at the turbulent flow. Turbulent flow. I'm seeing a rapid. Okay. I'm seeing it's sort of ungraded as well. Ungraded. I'm seeing nick points, of course. Nick points. All right. I'm seeing hard and soft rock. Hard and soft rock. Okay. Are we together, guys? There is a lot of obstacles, obstructions. Guys, here you can see with the flow of water, we cannot talk about deposition here. Uneven bedrock, that's correct. That's correct. That's the right term there. I'm not seeing anything that is to do with deposition here, guys. Can you see? This is turbulent flow. Here, the river is more energetic. There is higher velocity. It's something that we can also add. Higher velocity, which means the river flowing fast. River is flowing fast. Okay? All right, sharp. Are we together, guys? So these are some of the things that you can actually see. Turbulent flow. You can see turbulent flow. There is a rapid, ungraded, nick points, hard and soft rock, high velocity, river flowing fast. These are some of the things that you can actually see. It's flowing very fast. Are we together with these guys before we move on to the next question? This is more in the upper course. Okay. All right. Upper course. Okay. This is more in the upper course. Okay. Okay, Keletso, more in the upper course. That's where you've got your fluvial feature like your waterfall and your rapids. That's where we've got a lot of nick points. That's where there's more erosion, where we have got ungraded profile. So it's more in the upper course. It's more in the upper course of the river. Keletso, is it clear now? It's more in the upper course of the river. Exactly, that's correct, that's correct. So what will be the answer now? The fluvial landform feature depicted on the sketch is, okay, let's check now. What will be the answer from the options given? What will be the answer? What do we have there? What is the correct answer? What is the correct answer? It's not a waterfall, guys. That is C, it's a rapid. It's C, it's a rapid. The answer there is C, that is a rapid. It's not a waterfall. It's a rapid. It's not a waterfall. A waterfall is a rapid, okay? A waterfall, your layers of hard and soft rock are sort of horizontally layered for a waterfall. For a rapid, they are inclined. You can see the way they are. They are inclined, okay? So they're sort of tilted. So that is your rapid. The answer is C. Do we all understand, guys? Anyone confused? Anyone confused? Anyone confused? Are we moving at the same pace? Are we moving at the same pace? Can we move on? Give me a thumbs up. Okay, someone is saying no. What is the problem? What is confusing you, Keletso? This is, you can see, this is more of your turbulent flow. So we are saying your waterfall will be more like this. Okay? Your waterfall, it will give you something like this, okay? All right? Let's say this is more resistant, okay? And this is what, let's say I'm gonna take this. So your waterfall will be more like this. It's horizontally layered, okay? Horizontally layered, okay? You know this from your grade 11. Horizontally layered, okay? A hard and soft rock, okay? Okay, which means you have got your hard and soft rock. Then for your rapid now, for your rapid, you are going to have something like this. For your rapid, you are going to have something like this. You have got something like this, then gap, something like this, then gap. So this one now is your hard rock. This one is your hard. Here is your soft. Here is your soft. Let me just try to do like this. That is your soft rock. Okay. Here also is your hard. So your water will be flowing like this. It's sort of tilted or inclined. It will be flowing like it erodes here. Then it goes up like this. That's how you end up with a rapid. You understand? So rapids, turbulent flow. Exactly. To the, yeah, no wonder you have just, yeah. So rapid turbulent flow. That's basically what I'm trying to. Here I was just trying to explain it in a way that people understand. I try to make it as simple as possible. Like I'm taking you to grade R. That's the strategy that I was trying to use. So that's all. Are we together, guys, now? So rapid turbulent flow. Rapid turbulent flow. Here I was just going a little bit deeper, more inclined. Here is more horizontal layered. So are we together? Give me a thumbs up if it's fine. Give me a thumbs up. Give me a thumbs up, guys. Then we can move on. Thumbs up, thumbs up, thumbs up. I'm waiting for your confirmation. We want to move to 2.2.4. Thank you so much. What do we have here? The question is the flat. Guys, be attentive to detail. The flat, low-lying area along the banks of the river in the lower course. Okay, in the lower course. So what should come to your mind is, where this landform is formed, deposition is dominant. Deposition is dominant. Where this landform is formed, this feature. Deposition is what? Sorry, my spelling here. Dominant. So deposition is dominant where this feature is formed. Deposition is dominant. It's in the lower course. What is the answer from the options that are given here? Your answer now will be what? It will be your C. That will be your C. Are we together? You can see how attentive I am to detail. Flat, low-lying along the banks of the river in the lower course. On the floodplain, you know that we can also farm there because it's gentle. There's a lot of fertile alluviums that are deposited. So your answer is C. Okay. Sorry. Let's move on. So here, guys, before we answer this question, let's just talk about this. Okay. Wide and flat. Okay. Let's look at this now. So I want you to understand this. This is meander, river meander. Okay. Okay. This is the river meander. So you have to know the cross section of a meander, Sorry, cross section of a meander. So what happens? Let's do like this. Outer bank. As a bank actually, outer bank, what we have? We have erosion. We have erosion. Outer bank, what we have? We have an undercut slope. Undercut slope. Okay, the undercut slope is deeper because of erosion. Deep because of erosion. Okay, are you following? Because of erosion. My spelling here. Deep because of erosion. Then we have got what we call in the inner bank. Inner bank, please, asibengiachelete. We have got deposition. Deposition. Okay, what else? We call it what? A slip of slope. Slip of slope. Okay, it's more narrow. Okay, it's shallow. Okay, let me just take shallow. Okay, okay, what else? It's not deep, it's shallow. That's why I'm saying shallow. Okay, so that's what you need to understand first. So when you look at this, obviously the way it's moving, can you see here? Which means here, I'm going to say y here. Okay, so y, which one is our inner bank and which one is our outer bank? So y, when it's moving, which means there's more erosion at y here. So which means y is our outer bank. Do we all agree? Y is our outer bank and x is our inner bank. Okay, are we following, guys? So if we are to talk about the cross section, we are going to have something like this. We are going to have something like this. Okay, all right. Okay, so it means now we'll have this one is our x here. Then we'll have this one is our y here. Are you following, guys? Here at x, we have said that that's where there's more deposition. That's where there's more deposition. Here it's more deeper. That is where we have got our undercut erosion deep. Are we together? So you have to know the cross section of your meander. This one is more shallower, there is deep. Why? Because there's erosion. This is the outer bank. This is the outer bank. Here is the outer bank. Okay, this is the outer bank. Why? Here is the outer bank. Okay, are we together, guys? Do we understand the diagram so that we can move to the question? Give me a thumbs up if you understand the diagram. Give me a thumbs up. Thumbs up, thumbs up, thumbs up, thumbs up, thumbs up, thumbs up. Okay, good. Thumbs up, thumbs up, thumbs up. Thank you so much. Thank you so much. So let's move on now. Someone is saying, Nolwande is saying, I don't understand. What is the confusion, Nolwande? What is confusing you? What is confusing you, Nolwande? Can you be specific so that I know how to help? What is confusing you? Can you be specific so that the cross section I don't understand? Okay, no problem. So Nolwande, what we are saying now is, let me just do it slowly. This is the meander, the twisting and turning of the river. So the cross section of a meander, what happens is it has got two sides. Okay, the banks of the river, we have got the outer side, which is y here, where you've got our y. So the outer bank, the river there is flowing at a faster speed. The river there is more energetic. It's actually eroding. That's why we said y is our outer bank. There is erosion. So that gives us what? The undercut slope. It's more deeper because there is erosion. Are you following? Are you following? It's more deeper because there is erosion. Then when you look at X now, it's inside bank, which means when the water is flowing very fast here, inside bank here is slow at X. That's why we are saying there is deposition, and the slope that is formed, we call it a slip of slope. It's more shallow. You understand? Let me say it for the last time. This is our meander. It has got two sides, the outer bank, Y, and the inner bank, X. What do we have on the outside? The river is flowing very fast. on the what? Outer bank is flowing very fast. That's why there is erosion. That's why it's so deep. You understand? Giving us an undercut slope because there's erosion there. Then on the inner bank where we've got our X, the velocity there is lower or is less. So as a result, there is deposition and it gives us a slip of slope. So we are saying now our Y here is going to give us a what? Undercut slope. Undercut slope. Okay, undercut slope. Let me, okay, because of erosion that is taking place there. Okay, erosion that is taking place. Then our X here is going to give us a slip of slope. Slip of slope. Because of what? Deposition on the inner bank. That's what is happening. Because of deposition on the inner bank. Nolwande, is it clear now? Is it clear now? Is it clear now? Nolwande, is it clear now? Thank you. Thank you so much. Thank you so much. Let's move on to the question now. Let's move on to the question. All right. So what is the answer here now? Is saying the slope at X on the inner bank of the river is referred to as this one, the inner bank. Remember, I've talked about the inner bank. What is the answer here? The inner bank, what is the correct answer? Where deposition is taking place. That is your slip of slope. Isn't it? That is your slip of slope, which means your answer is D. That is your slip of slope. Okay, sharp. Then forms at the, when the meander loop is cut off from the mainstream. What forms when the meander loop is cut off from the mainstream? What forms? What forms when the meander loop is cut off from the mainstream? Let me try to demonstrate this one. Let me try to demonstrate this one. All right, I'm gonna do something like, all right. All right. Okay. So what we are simply saying, guys, is this is your meander loop, okay? So what happens is with this, there's going to be more erosion here, more erosion there as well. This will narrow the neck of the meander, which means at some point it's going to end up being bypassed. We are going to end up having something like this, okay? Something like this. Then we have got, it's now closed because of deposition. We still have this, of course, it's gonna flow direct. This is gonna flow direct. So we're gonna end up with something like this. So this one will give us an oxbow leg. That is an oxbow leg. An oxbow leg. All right. So this has been cut off as a result of from the meander loop. Okay, this is a meander loop. Okay, so in the outer bank here, on this side, erosion there, which means here there is what? That is okay. There is erosion here, meander neck, sorry, erosion there, which means it's going to bypass and cut off. That's what has happened here now. It's now flowing direct, which means this one has been cut off now. That is our oxbow leg. That is our oxbow leg. That is our oxbow leg. Is it clear? 2.2.6. That is a neck. Of course, let's keep. That's correct. It's a neck. Sorry. It has been narrowed to give us a. So the answer there is C. The answer here is what? Is C. The answer is C. Is it clear now? Let's keep. That's correct. That's the meander neck. Thank you so much. Thank you so much. Let's move on. 2.2.7. The benefit of natural levees. What is a natural levee? Natural levee, in simple terms, natural levee, these are raised banks that are formed when a river is flooded. Okay. River is flooded. Okay. First, okay. Continual deposition on the river banks will result in raised riverbanks. All right. So what we are saying in simple terms, this is formed when the river is in flood. Raised banks that are formed when a river is flooded. Continual deposition, which means there is continual deposition. Remember, when a river is flooded, okay, when there's a flood, some of the sediments that are carried by the river, some are heavy, some are light. So these sediments are deposited here on the banks of the river. They are deposited on the banks of the river. So they continue to pile. They continue to pile over a long period of time. That's how they raised the banks of the river. So this is the continual depositing of sediments on the banks of the river, which raises the banks. That's what gives us the natural levees. That's what the natural levee is. It's formed due to continual deposition of sediments on the banks of the river, which means now they are raised here because of continual deposition that takes place over a long period of time. They are also helpful in that they help to control flooding to the nearby floodplains. Are you together? Are we fine with the explanation of natural levees? Raised banks. They are formed due to continual deposition on the banks of the river. So the sediments are deposited whenever a river is in flood. That's how these banks are raised, giving us what we call the natural levees. Are we together, guys? Is it clear? Is it clear, guys? Can you confirm if it's clear, guys, so that we can move on to the question? Everyone confused with natural levees? Raised banks, that is the simplest definition. Raised banks, they are formed as a result of continual deposition of sediments on the banks of the river when the river is flooded. So the sediments are deposited continuously up to the point whereby the banks are raised up. That is your natural levees. Are we together? I can see all the guys understand. Okay, let's move on. So now the question is saying now, I want you to be attentive to detail. The question is saying the benefit of natural levee to the floodplain. What will be the advantage of this natural levee to the floodplain? From the options that are given, what will be the option? I said it indirectly if you're paying attention to my explanation. And one day, I think you cooked them, you microwaved it, you clogged it. Okay, so there the answer is what? Is B. That is the advantage. Reduced flooding. That is the benefit. Remember, when they are raised, which means now when the river is in flood, now the water will actually continue flowing within the stream. It's not going to go to the sides of the banks. That's why we are saying it's reduced flooding. All right. Are you following, guys? Can we move on to the next one? It's fine. Let's move on to the next one. This one now. Okay. Deltas form at the river mouth when the following conditions okay. So what is a delta? What is a delta? Let's start there, guys. Because we cannot just answer something that we don't know. What is a delta? What is a delta? What is a delta? Let's define a delta. Pen-shaped depositional feature formed at the mouth of Okay. River. All right. Simple definition. I simplify here. That's why I'm called simplified FET geography. A fan-shaped depositional feature formed at the mouth of the river. That is your delta. So it means where it is formed, the condition has to favor deposition. So which conditions here favors deposition here? Which conditions favors deposition here? Which conditions favors deposition from the options given? So it is a deposition, fan-shaped depositional feature that is formed at the mouth of the river. So which conditions here favors deposition from this? Which conditions? That is 1 and 4, isn't it? 1 and 4. That makes it what? What is the answer now? Shallow seabed and what? Small tidal range, which means your answer 1 and 4 is what? Is D. So you look at the condition that favors deposition. So that is your D. Okay. Okay, it's fine. Are we fine? Let's move on to the next paper. Let's move on to the next paper. Let's move to the next paper now. We are fine with this one. We are done. Let's move to 2025. We are moving on to 2025 now. 2025. All right, 2025. Let's answer right away. Okay, let's just analyze this. What can you see? The main concept there is drainage basin essay. Okay, drainage basin. Okay, in South Africa. In South Africa. Okay, so remember the first paper that we started with. So I'm not going to, we'll just go straight to the question. The first paper that we started with, guys, you still remember we managed to label everything. So this is what we have now. So the key, vegetation, the permanent river. Obviously, the permanent river, what does it do? It flows throughout the whole year, isn't it? Flows throughout the whole year. The whole year. All right. Then if it's what is periodic, it flows seasonally, isn't it? Flows seasonally. Okay. All right. Periodic, when there's rainfall, that is flow seasonal. Okay. That is your vegetation here. Obviously, we are going to see it at some point. Okay. Let's now, the question is, refer to the sketch below based on the drainage basin. Complete the statements in column A with the options in column B. Write only Y or Z next to the numbers. All right. Let's get to our questions now. I remember the main river A and its tributaries. What is it called? The main river A and its tributaries. What is it called? What is the answer there? Main river A and its tributaries. What is the answer? For 2.1.1 is Z. It's a river system. It's a river system. That is your river system. It's your river system, guys. The river and its tributaries. That is your river system. It's not the catchment area. It's not the catchment area. Catchment area, we are looking at the whole area which captures the rainfall when it falls. That's much of your more of your catchment area. This is a river system. That is your river system, the main river and its tributaries. The answer there is Z. Are we together? How about 2.1.2? In an area B, separates one stream from another. Separate one stream from another. In an area B, separate one stream from another. What would be the answer for 2.1.2? What would be the answer? Come on, guys. Come on, guys. This is the same river system. This is the same river system. So that makes it what? An interfluve. Guys, how many river systems do we have here? We have one. This is the main system from the source to the mouth. So that's an interfluve. That's what makes it to be an interfluve. It's not an watershed because we have got one river system here. So this highline area which separates these two tributaries becomes an interfluve. It's not a watershed. Watershed, remember, we are supposed to have two river systems or two drainage basins. The highline area that separate those two drainage system or river system, that's the watershed. So the answer here is an interflow. This is one drainage basin, so that is an interflow. Are we fine with 2.1.2? Give me a thumbs up if you are fine. Thumbs up, thumbs up. The answer there is Z, it's an interflow. Anyone confused? Sharp. The area HC will have, this area HC, what will it have? Is it going to have low or high infiltration rate? What will happen? What is the effect of vegetation on infiltration? Where we have got dense vegetation and sparse vegetation, where are we likely to have high infiltration? What will be the correct answer there? Vegetation, remember, it intercepts the water when it rains, so it means water will be able to infiltrate. So we are likely to have high here. Our answer is Z. Our answer is Z. Okay. Our answer is Z. Anyone confused? Okay. The confluence of the sketch is located at. The confluence is located at, okay, where two tributaries meet. Where is the confluence? Is it at E or F? Where is the confluence? Is it at E or F? Where is the confluence? It's at E. That's correct. So let's get our answer there. It's what? It's Y. That is Y, our answer there. Then 2.1.6 will increase in area G due to steep slope. What increase because of steep slope? When the gradient is steep, it means water is not given enough time to infiltrate. So it starts to run off. So what will be the answer there? 2.1.6. The answer is Z. If it's steep, water is not given enough time to settle. So it starts to run off. The moment they mention this, guys, this should guide you. The moment they mention this steep slope encourages more surface runoff. So the answer there is what? Is Z. The answer here is Z. Anyone confused? Oh, sorry. I skipped 2.1.4. Sorry. Thank you. All right. Sorry. Thank you. The river at D. What is the river at D? Check here, your key. 2.1.4. Is it permanent or periodic at D? Sorry, guys. 2.1.4. Is it permanent or periodic? It's permanent, right? Use your key. It's permanent. That is why. Thank you so much, guys. I don't know how I skipped that one. Okay. So now we are on 2.1.6. Do you all understand 2.1.6? Do you all understand 2.1.6? 2.1.6, give me a thumbs up if you understand. 2.1.6. What we are saying, Nolwandene and Leskid, is where we have got the steep slope, water is not allowed to settle. It starts what? Flowing. So steep slope encourages surface runoff. Gentle slope, water is allowed to settle. Then it starts the process of infiltration. So what directs you towards the answer is, will increase at G due to the steep slope. Already, what encourages, steep slope encourages more surface runoff than infiltration. Steep slope encourages more surface runoff than infiltration. So that's why we said the answer is Z. Are you fine now? Leskid and Nolwande, is it fine now? Wami, I'm coming to you. I'm going to respond to your question. Lawami, I'm going to respond to your 2.1.4. Let's finish up with, okay. Okay, sharp. So I'm fine with this, guys. Wami, let's look at our key. Wami, look at the key. Wami, look at the key. Permanent river, periodic river. Look at your D. That is permanent. Can you see? If you look at this, this is periodic. Wami, are you answered now? Wami, can you give me a thumbs up if you concur with what I've just said now? Wami, can you give me a thumbs up? You have used the key. Yeah, thank you so much, Wami. Thank you so much. Here, guys, we don't leave people behind. We move at the same pace. The stage of the river at H is there. Let's go to H. What is the stage of the river? Which course of the river is it? At H, which course of the river is it? Is it the lower course? Is it the middle course? Is it the upper course? At H, which course of the river is that one? I'll take lower. I'll take lower because it's close to the river mouth. I'll take lower. Okay. All right. Let's see. Okay. I'll take lower, which means our answer is what? 2.1.7. It's Y. Ah, come on, let's kid. How can you say upper course? Meander, oxbow leg. Check here. Let's kid, check here. This is close to the river mouth. That is your lower course. Let's kid, are you getting it now? It's not upper course. That is the lower course. That is the lower course. Thank you so much. Thank you so much if you understand now. Thank you so much. So you see, guys, you see how you get some of these answers wrong. Okay. Does a meander happen in the lower course? A meander, okay, Scuba, Mabazo, a meander, you find it both in the middle and lower course. It's more in the middle and lower course. You find it in both middle and lower course. Thank you so much. You find it in the middle and lower course. But we are answering as per this diagram. It's more to the lower course. You find it in both the lower and the middle course. Okay? You find it in the middle and the lower course. Is it fine now, guys? All right. I want us to do something for 2.1.8. Do you still remember, guys, the types of rivers that we have? Types of rivers. Do you still remember, guys, the types of rivers that we have? We have got what? Episodic. We have got what? What else? For episodic, what we have? We have got periodic, which is also known as what? Seasonal. Okay. Which is also known as what? Non-perennial. Perennial. Then what we have? We have got our perennial. Perennial. All right. Which is also permanent. Permanent. Then we have got our, what is the last one? Exotic. All right. Do you still remember these rivers, guys? I want to explain something with this. That's why I'm introducing these 4 types of rivers. So your episodic, it flows as soon as it rains. Like think of mostly the rivers that you have in the deserts. As soon as it rains, then it starts flowing. That is your episodic. Your periodic is also known as seasonal and is also non-perennial, which means it flows seasonally. It flows seasonally. Then your perennial, it flows throughout the whole year. Then you have got your exotic. It starts from a humid area, then it passes through a dry area. Like think of your Nile River. Up the Mediterranean Sea, it passes through part of Sahara, then it goes down. You understand? That's more of your exotic. It starts from a humid area. So it means at some point, your exotic, if you look at it, it's also more of a permanent because it has got a permanent supply of water. It's more of a permanent river as well because it flows throughout the whole year. My spelling for permanent there, my bad. Okay, permanent. Okay, sharp. Are we together with the different types of rivers that we have? I want to explain something, guys, before we answer this question. So I'm going to do it like this. Let me draw something here. I'm going to do something like this. I'm going to do this. Then I do this. Then I'll do this. Okay. I'm going to do something like this. Okay. This is my, all right. Then I'm going to, all right. What I'm trying to do here, guys, is I'm trying to explain the type of rivers in relation to the position of the water table. That's what I'm trying to do. So let's start. 1, this is your 1 day. This is your 2. This is your 3. So this first one here is rain season, rain season, rain season, water table, and this one is your dry season water table. That season water table. All right. So when we are looking at this, guys, I have drawn this. I want to explain something, guys. So the flowing of your episodic river is not affected by the position of the water table. So your 1 is episodic. Your 1 is what? Episodic. Episodic river. What we are saying now, the flowing of our episodic river is not affected by the position of the water table. This is the water table, which is the level of water underground, the upper level of water underground. So the water table in the rain season, it goes up, and in the dry season, it goes down. That's what I'm trying to illustrate here. So on this diagram, number 1 is your episodic river, which means its flow is not affected by the position of the water table. That's why you see it here. It's not affected. The water table is not cutting across the riverbed. That's why you see it like this. Then on number 2 now, what we have on number 2 is your seasonal, okay? Is your seasonal, which is also your periodic, which means now its flow is also affected by the position of the water table. When we have received some rains, there have been more infiltration, the water table rises, so it supplies water to the periodic or the seasonal river. You understand? There's water that is coming through rain. There's also water that is supplied through the water table through the process of through flow or base flow. That's why you see the water table for the rain season, it cutting across only the riverbed of number 2, which is our seasonal. Okay, because it is also affected by the position of the water table during the rain season. You understand? So that's why the rain season water table is cutting across the riverbed of our seasonal. Then number 3, we have got now what we call the perennial now. That we have got the perennial, okay, which is your permanent now. So this one flows throughout the whole year. That's why when you look at it now, the water table, both the dry season and the rain season water table, is cutting across the riverbed of our permanent or our perennial river. It shows that this one now, it flows throughout the whole year. Even when we do not receive rain, it still has the source of water from the water table. That's why you see it like this. So 1 is our episodic, 2 is our seasonal periodic, and 3 is our perennial permanent. Exotic is permanent. Yes, exotic is permanent. It has got a constant supply of water. Remember, it starts from a humid area, then it passes through a dry. So it does not dry up. It flows throughout the whole year. That's what makes it permanent. So exotic, indeed, it is permanent. Are we together, guys? Is this explanation clear? You can give me a thumbs up. Give me a thumbs up, guys. If I've cooked, please, 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 please give me a thumbs up. Is it clear, guys? We have not yet answered the question. I was just trying to explain the types of rivers and how the position of the water table affect them. This is how. Then how is perennial permanent? Perennial, it flows throughout the whole year. That makes it permanent. Let's keep. Perennial flows throughout the whole year. What makes it permanent is it flows throughout the whole year. The permanent is coming from it flowing throughout the whole year, which means our seasonal is temporary. That's basically what we are talking about. Let's kid. Are we together? Are we together? Thank you so much. Let's answer the question now. Let's answer the question. The water table in I will resemble. What is the correct answer for 2.1.8? What will be the answer? The water table at I. Let's go to the diagram. At I, What will it resemble? Water table at I, what will it resemble? Look here. Can you check here? Periodic river. What I was explaining now, let's go back now to the answers. Water table at I. What is the correct answer then? What is the correct answer? What is the correct answer? For 2.1.8, what is the correct answer? What? Yeah, you see now. The correct answer is what? Is Z. That's correct. That is Z. It's Z. Okay. Thank you so much, guys. Is there anyone confused with this? Or we are fine? Anyone confused? Anyone confused? It looks like we are fine. It looks like we are fine. All right, let's move on to 2.2. Let's move on. Okay. What is confusing you? No problem. Did you hear my explanation when I was explaining this? That's the reason why I had to start by listing the type of rivers. And after that, I explained how the position of the water table influence or affect the flowing of all these rivers. So what is happening now? If it's periodic, like here, let's go back. This one, periodic, is periodic at Y. Here, you can see it's periodic. Here is periodic. This is periodic at Y according to our key. Periodic river, it flows seasonally. Let's go back now. So our seasonal river is only affected by the rain season water table. When it goes up, it's only affected by the wet season water table. You understand? That's why it's cutting across the riverbed only. But the dry season water table is not cutting across the riverbed. So this shows that it flows seasonally. So this one flows seasonally. Okay? Flows seasonally. Okay, that's what is happening here. So this one flows seasonally. This one, you can see both the wet season and the dry season water table is cutting across the riverbed. So that's what makes it to be what? Perennial or permanent. Okay, perennial, okay, permanent, or whichever way you want to name it, permanent. Okay, okay, is it clear now? No, Luande, is it clear now? So we are saying now, that's why I used this diagram to explain before I move on to look at the question. I wanted you to have a bit of a foundation of how the water table influence or affect the flowing of rivers. Is it clear now, Nolwande and Molemabilo? Is it clear now? Can you confirm? Nolwande, I can see you understand now. Mabilo, is it clear now? Thank you so much. Thank you so much. Let's move on to 2.2. All right, so here we are now. Let's define. Is the concept that is being assessed here is river capture. What is river capture? What is river capture? Let's define it. Let's define river capture. Let's define river capture. Let's define river capture. What is river capture? Let's analyze the diagram, guys, first. Of course, it's stealing. There's something that is missing. I want you to include the part. How does it steal? Because it's more energetic. You understand? So if you just say river stealing from another river, what makes it to have that potential to pirace, that potential to steal? So we are saying this is when an energetic river captures the headwaters of a less energetic river. Less energetic river. So that is your river capture. When an energetic river captures the headwaters of a less energetic river. So please, if you just say river stealing water from another river, it's not. Let's make it more geographical. Let's make it more geographical. when or more or an energetic river captures the headwaters of a less energetic river. We have got two rivers. The other one has got more, is a more energetic river. The other one is less energetic. So the more energetic, what it does, it captures the headwaters of a less energetic river. Remember, this is a concept. So usually this is a 2 marks question. So you have to make sure that you answer it correctly when a more energetic river captures the headwaters of a less energetic river. So what you need to understand, guys, is these two diagrams. Okay, these two diagrams is what you need to understand. So we have got two rivers, X and Y. X and Y. These are the two rivers that we have. So obviously what separates them here is the watershed. What we have here is what separates them is the watershed, because it's separating. These are the two river systems, two rivers that are separate. So what separates them here, what we have here is the watershed. Okay, what separates them here is the what? Sorry, let me, I'm highlighting now on the river instead of highlighting on the watershed. Okay, let me just try to rub it off. Okay, I want to remove this. Okay, so what separates them here, what we have here, the high-lying area here, it becomes more of your watershed. Okay, so you've got this river and this river. These are the two rivers that we have. Okay, so you have to understand the before and the after. So what happens now is our river X now, through headward erosion, okay, through what we call headward erosion, okay, headward erosion, okay, it can be forward or backward, our headward erosion, it can be forward or backward, but in this instance it's more of backward. It's cutting back to its source, which means it's going to cut back to its source here so that it captures Y. That is your backward erosion that is taking place, or the process of abstraction that is cutting back to its source. This is the more energetic river, river X, is going to cut through the watershed through the process of abstraction, or through what we call headward erosion, that is backward headward erosion. So that's how it's able now, after river capture, to capture the headwaters of this river Y. You can see now what is remaining now is this here. It becomes what we call a misfit. This one becomes what we call a what? A misfit. Okay. Then what we have, this one here, it becomes the elbow of capture. What we have here, I'm going to highlight it here, what we have here. Then I'll take it, this one, it becomes your elbow of capture. Elbow of capture. Elbow of capture. Then what we have here in between, the gap that we have here, the gap that we have here becomes our wind gap. This one here becomes our what? Our wind gap. Becomes our wind gap. Okay. So this, that the one that is captured, yeah, where is the Oaks Volley coming from, Saim? What's happening now? The one that has captured the less energetic river here, it becomes what? The capture stream. The capture stream. Okay. The one that has been captured, whose headwaters has been taken, becomes the what? The captured stream. So what will happen here now? On the one that is the capture, there's going to be it's going to be more energetic, okay, energetic, or more erosive, high velocity, high velocity. Okay. The one that has been captured obviously will become less energetic. Okay, the opposite of what the capture stream is. It will be the opposite of what the capture stream is. Okay, opposite of what the capture stream is. Okay, so now let's go to the question. Are you fine with this, guys? Are you fine with the explanation that I've given now? You want to go to the questions? Are you fine with the explanation? Are you fine with the explanations? So that I can move on to the questions. Are you fine with the explanations? All right, sharp. Give me a thumbs up if you are fine with the explanations, so that we can move on to the question. All right. Are you fine with the explanation? Thank you. Let's okay, check here. This is the misfit. It will dry out. It will dry out with time. Obviously, it does not have a constant supply of water. Why? Because it has been captured now. It has been redirected to the more energetic river. So the one that is left, the misfit, now with time, it will dry out. The volume of water in that will decrease. Okay. Are we fine now, guys? We want to move on to the question. Any question? Any questions? Any question? Any question? Any question? Balawuz, are you fine now? Any question? Can I proceed to the next question? Can I proceed to the question? Okay, thank you. Thank you so much. All right. So here what we have, a river that has its water diverted into another stream is referred to as, what is the answer? A river that has its water diverted to other stream. What is it called? What is the answer there? 2.2.1, what is the answer? I want to hear it from you. Guys, how can it be captured? It's the captured moose. That is the captured. Remember, it has this water redirected, diverted to another stream, which means the water is now flowing in there. Okay, so that is the captured, not captor. Check here, guys. River that has its water diverted into another river, which means it has been captured. The water has been rediverted. The capture stream has captured the captured stream. That's basically what you're talking about. So this one, you see here, it has been captured. So now is the capture, X becomes the capture stream. That's basically what we are talking about. So Y has been captured. So that is the captured stream. That is A. Are we together, guys? 2.2.1 is A, captured stream. Are we together? That is A for 2.2.1. Anyone confused? Anyone confused? Are we together for 2.2.1? Are we together? Can you confirm, guys? Talk to me, talk to me, talk to me. Talk to me, talk to me, talk to me. All right, let's move on to 2.2.2. All right, what is the answer for 2.2.2? River flowing with over areas with dash are more likely to be the capture stream. The more energetic the surface over which it flows. A river that flows over are more likely to be the capture stream. What is the answer? Okay, that would be, I'm seeing someone who have written the correct answer there, which is C. That's correct. The answer there is C. That is correct. That's why it's able to cut through the watershed. Then evidence that the river capture has taken place in sketch B. What evidence is there that the river capture has taken place in sketch B? What is the correct answer? 2.2.3. What is the correct answer? What is the correct answer, guys? Let's go back. What if between X and Y, which one has been captured? X and Y, which one has been captured? We are choosing the options. There are options that are there. River X has captured the headwaters of Y. Let's go back. River X here has captured the headwaters of Y. Let's go back. Let's go back. What is the correct answer? Check here. River X has captured the headwaters of Y. That is your answer there, which is C. That is your answer, which is what? C. That is your answer then. Are you following, guys? Are you following? Is there anyone confused? Then 2.2.4, the cause of river capture. The cause of river capture is shown in sketch B. What is the cause of river capture? From the options given, what is the cause of river capture? What is the answer? I can see Lauzi and Scuba. The answer is correct. That is what? C. That is correct. Let's move on to 2.2.5. 2.2.5. The part of the river that has less water after river capture is known as, that has less water. The part of the river that has less water. This one. We are talking about this one. We are talking about this one. What is it called? That has less water. That's the one we are talking about. Let's go back. That has less water. What is it called? That is your misfit. That is what? D. Okay. Then river X has more erosive power. Let's check. River X has more erosive power after the river capture because of what makes it to have more erosive power? 2.2.6. What makes it to have more erosive power? From the options, as Buddha is cooking today. What makes it to have more? Okay, what is the correct answer? I want you to think, guys. I want you to think. Stop guessing. Stop guessing. Look at the options and choose the right answer. Stop guessing. Stop guessing. Which one explains why it has become more erosive? That is your A. That's correct. That's your A. So you see how you lose marks, guys. Do not rush. Read to understand. Be attentive to detail. Some of you are rushing, then you end up choosing the wrong question, the wrong answer. Okay, sharp. Let's move on to 2.2.7. The physical. Okay. This one reads, next one, the physical natural impact of river capture on the capture stream. Remember, the capture stream is the one that has captured the less energetic river, the capture stream. So the physical natural impact of the river capture on the capture stream, the one which is going to become more energetic, the one which is going to have more high velocity, the one, okay, what will be the answer? 2.2.7. Obviously, I'm looking at this now. We are likely to have river rejuvenation taking place. We are also likely to have water flowing fast. River rejuvenation taking place and water flowing taking place. Remember, okay, so our answer will be what? 2 and 4. That will be C. That will be C. That will be C there. Okay, we are moving on to the last paper now, the Gauteng province paper. That's where we are moving on now to. Let's do the Gauteng now. All right, this is the last paper, guys. This is the last paper. Let's just do this now. So what can you see here? We are moving on to the next one. What can you see? What can you see? Let's talk about what you can see here. There is a waterfall, right? There is a what? A waterfall. That's all I can see here. There is a waterfall. Okay. Obviously, what comes to your mind? Upper course of the river. Upper course of the river. Upper course of the river. I can see there at B. I can see a plunge pool. I can see a plunge pool. Okay. I can see a plunge pool. Of course, a waterfall is also a neck point. Let me put it that way. A waterfall. All right. It's a neck point there. That's a waterfall. It's your neck point, of course. I can just put it like that. Okay. So this is what we can see. Obviously, this is your resistant rock. This is your hard rock here. This is your soft rock here. Soft rock here. So what happens here, guys, is obviously it takes time to erode a harder rock. It's more resistant. That's why you see the undercutting that is taking place here. The undercutting that is taking place is happening on the softer rock, which will end up with this outcrop at some point. It will end up as an overhang, which will collapse into the plunge pool. Plunge pool with Kai. So I'm just saying, just in general. So this one, which means if it keeps on undercutting, rejecting backwards due to backward erosion, it's eroding the softer rock, which means this hard rock will not have support. That's why it's left as an overhang. Then it will eventually fall into what? Our plunge pool. So this is your waterfall. This is your waterfall. So the question now reads, the feature that develops at B at the waterfall below is, what is the correct answer here? What is the correct answer? 2.1.1, what is the correct answer? Of course, it's C. I'm seeing some people, they've already given the answer, it's C. Okay, then the next one reads, a natural levee is formed. Remember, we have already talked about this. What is the correct answer? 2.1.2. 2.1.2, a natural levee. It's not going to be closed, clouds. Why? Because remember, the river has got more energy. The force of this water, that's why you see these sediments, they sort of have been moved away from this plunge pool. Because this one, obviously, the pressure, the velocity, the energy of the river, it keeps on clearing this plunge pool. You see where it's moving towards. Okay, so it's not going to be closed. Okay. Mlauzi, is it clear now? What I've said just now. So which means our 2.1.2, of course, it's C as well. That's correct. So the plunge pool is not going to be closed. Thank you. Then 2.1.3, a floodplain is an area in there. Where do we find our floodplain? Obviously, it's more in the lower course. Okay? Which experience flooding during periods of, what would be the answer? What would be the answer there? Our answer will be D. That will be high here. So which means our answer is what? D. That will be our answer. 2.1.3 is D. All right. Let's move on to 2.1.4. Braided streams. Let me demonstrate this one. Assuming we have got our river here, assuming that we have got our river, I'm going to make it more straight. So what happens now is when the river is carrying sediment, some of them are soluble, some of them are insoluble, some are heavy, some are light. So what happens, it deposits the heavy sediments on the stream. That's what it does. It deposits some of the sediments in the stream. So when the water is flowing now, it's going to give you multi-streams because of the presence of the sand islands. So this one is going to be more like the sand islands in the stream. Sand islands. Let me just try to write it in small letter. Sand islands. Okay, so we have got multi-streams now. They're going to end up with what? The multi-streams. Multi-streams, okay? So the water will be flowing now around this sand island that has developed as a result of deposition of heavy sediments in the river stream. Okay, so that is your braided river. This is what has been deposited, forming sand islands. The circles, what has been deposited. So obviously, since it is highlighted that braided stream developed in the lower course of the river, obviously you know in the lower course of the river, deposition is more dominant. There is more deposition. So that should help you. So your answer is what is A. Is A. All right, sharp. Let me verify something, guys. Just a minute. Okay. Sharp. All right, sure. I'm back. All right. So are you following, guys? So your answer there is A. Sharp. Let's move on. Then here, what we have, identify the fluvial landform. All right, which fluvial landform is this? Identify the fluvial landform. Which one is it? The twisting and turning, of course, you can see here the twisting and turning. That's your meander. That is your meander, which is what? B. That is your B, meander. Okay. Then what do you have? The following sketch represents the formation of, what is the correct answer, guys, here? The formation of is the formation of what here? 2.1.6. What is the answer? That is formation of an oxbow leg. Formation of an oxbow leg. This is straight and to the point. Then we have got a delta can be described as, remember I've already explained a delta. It is a fan shape, fluvial feature, depositional fluvial feature that is formed at the mouth of the river. Which answer is correct from the options given? What is the answer there? Guys, C. How can it be C? Whatever answer you're going to choose is supposed to include deposition. It's supposed to include deposition. That is A. That is correct. Guys, can you see how you lose marks? Most of you, I'm seeing you are rushing. You are rushing. Read to understand. You are rushing. You are rushing. That's what is happening. Okay. Let's move on now to 2.2. Are we fine with this one? Let's move on to 2.2. We are almost done. I've already explained river capture, guys. I've already explained river capture. I've already explained river capture. So I've already explained river capture. So let's do it like this. D. Let me do it like this. D. Elbow of capture. I've already explained this, guys. Then we have got our E. Our E. It becomes what? The wind gap. Then we have got our wind gap. We have got our C. It becomes what? The misfit. Okay. Sharp. So let's go to the question. It's saying, I did not read the question here. Below, refer to the diagram below, read the statements and choose the appropriate words in brackets, which will make the statements true. Okay, let's go now. So stream A, what is it? So you are using both diagrams. This is what helps you to identify whether it's a capture or captured stream. So our answer there is capture. Is the capture stream. Okay, that's correct. Then number 2.2.2 is not captured, it's capture. Lead K is the more energetic, is the capture. Is the capture. What is more? Okay, that is your head what? That's correct. Okay. That is your headward. 2.2, that is your headward. Okay, I'm seeing Spuda, you are saying no. What is happening? What is happening? What is happening? Spuda, what is happening? Spuda, I saw you saying Lady K is not captured, it's captor. It's captor. Ah, A is A. Why? Okay, Spuda. Which one is more energetic? Between. All right. Okay, let's check. All right. Are we together, guys? Are we together, guys? Is it fine now? Okay, sharp. If you understand, then it's fine. Then 2.2.3. So thank you so much, Spuda. Thank you so much. Please, you have got the right to argue, okay, to ask if you do not understand. If something you don't agree, it's your right. Ask. Okay. River C is identified as the misfit because it is, what is the correct answer for 2.2.3? What is the correct answer? 2.2.3, what is the correct answer? What is the correct? Yeah, it's small. Okay. Then 2.2.4, what is the correct answer? What is the correct answer? 2.2.4. It's more than 9, it's more than 45. It's more than 45. You can see it's more than 45. It can be 45. We can take 90. It's 90 then. It's more than 45. It's more than 45, guys. Then E. What is E? What is our E here? What is the correct answer? What is our E? What is our E? Is the wind gap. That's correct. Wind gap. Then wind gap, that's correct. A possible cause of river capture. What is a possible cause of river capture here? What is a, okay, what is the possible? I've labeled it, Mus. Capture stream. I've labeled it capture stream. What would be the answer here? Possible cause of river capture. What is the correct answer for 2.2.6? 2.2.6. Come on, guys. Reduced discharge. That's wrong. That's wrong. That's wrong. Isostatic uplift, which is more like your tectonic uplift. What it does is it gives the river more energy. It gives, yeah, exactly, isostatic. That is the correct. It's more like tectonic uplift, okay? Isostatic uplift. Uplift. I'm saying it more than, okay, all right. Can you check, is this 90 degrees? Okay, if you can check here, your elbow of capture is more than 45. It's more than 45. It's more than 45. You can check. Why I'm saying it's more than 45 degrees. Could someone explain? Here, when you look at your elbow of capture here, in terms of degrees, this is more than 45. All right, let me do it like this. This is more like 90. This is 45. This is 45 here. The whole of this from there up to there is more. That is your 90. Are you following? The idea is to say only that it's more than 45. As long as a number is more than 45, it's correct. That's why we have taken the 90. That's why we have taken the 90. That's why we have said it's more than 45 from the options that are given. It's more than 45. It's not 45. Are you following? Okay, Nolwande, are you fine now? Thank you so much. Okay. Then after capture, river A what will happen to river A after capture? What will happen to river A? It will increase. That's correct. It will increase. That's correct. River A will increase. Okay, in its volume. It has captured the less energetic river, so now it will increase its volume. It will increase. It will increase. Remember, our river A is the captor. So definitely it's going to increase. The volume is going to increase. Nolwandle is going to increase, not decrease. It's going to increase. There's going to be more volume of water in the captor stream. Nolwande, are you following? I see you have written decrease there. It's going to increase. There's going to be more volume of water. There's going to be more volume of water in A, which means it's going to increase. Nolwande, can you confirm if you understand now? And Temba, can you confirm? I don't get it. A, okay. This is your capture stream that has captured this river. So now all the water is being diverted to the capture stream. Hence is now having more volume of water. That is your river A. Are you following now? Nolwande? Your river A is cut through the watershed and it is now captured this river, which means there's more water flowing in it, so the volume increases. Temba, thank you for understanding. Nolwande, is it clear now? Nolwande, can you confirm if it's clear now? Can you confirm if it's clear now, if you understand? Nolwande, what is confusing you? A is the capture stream. Remember, our A is the capture stream. It is the more energetic. It is the more, let me just put it here, more energetic river that has captured the less energetic river. That's why the water increases. Exactly. So the river that has been captured, it's adding water to A, which is the capture river. So that's why we are saying now the volume of the water will increase. So the water from this river is now diverted. The water from this river has been diverted. To this river. This is what has happened here. So it means the volume has increased. That's basically what we are talking about. So A has got more water. Are you getting it, Nolwande? A now has got more water. It's the capture stream. So the volume of water has increased. Thank you. If you understand, thank you so much. I don't like leaving people behind. I just try to make sure that we move at the same pace. So the last one, guys, then we call it a night. River C will have a drainage basin after capture. River C, what will happen to River C? What will happen to River C after capture? What will happen to this River C, which is our misfit? What will happen? What will happen? Remember, the source of water has been taken. What will happen? Which means the answer now is what? Is smaller. Is smaller. Okay. Okay. We are choosing from the options here. You see, Nolwandi, let's look at the options that are here. Because if you are going to write dry out during that time, it means you won't get the answers correct. Read the question, River C will have, you choose from these two options. That's what you are doing. You are choose from the two options. So which means your answer there, of course, is correct, but it's not according to what is being asked here. Thank you. Sharp. So boys and girls, this takes us to the end of our live for today, where we revised 2023 paper, 2024 and 2025 NSC. Then we also revised the Gauteng 2023 preparatory paper. That's what we did for today. So today is short questions. Then tomorrow we are going to go through the 15 marks questions. Tomorrow we are going to go through the 15 marks question. Let's make a date. Let's make a date tomorrow. Let's meet tomorrow, same time, 8 to 10. Then on Friday, we don't have a live. On Saturday, we have a GIS live. On Saturday, we have got a geographical information system live. it's only about GIS for Saturday. GIS, Saturday, GIS live. Then on Monday, we have got map interpretation live on Monday. Then Tuesday, we have got map calculations. So this is the lineup of our lives. So tomorrow is still Geomorphology Part 2. Then on Saturday, GIS, only GIS. We'll be looking at GIS only on Saturday. Then on Monday we don't have. On Monday, map interpretation only. Then on Tuesday, map calculations. Then after we are done, we move on to paper 2. Please, before you go, can you tap the screen, guys? Can you tap the screen? Tap the screen, tap the screen, guys. Let's get to 20K. There's only 9,000 likes. Guys, from 800 people, from almost like 900. Tap the screen before you go. Thank you so much, guys. I don't know if there's certain things that you want me to emphasize on, especially tomorrow on the 15 marks question, so that I will know the question to choose from the papers that I have. Is there some of the things that you that are confusing you that you want me to pay more focus on? Is there certain things that you feel that you do not understand that you want me to pay more focus on? Is there? Thank you so much. Thank you so much. Thank you so much, mates. I really appreciate. Okay, the paragraph question. Thank you so much. Okay, the paragraph question. Anything specific for tomorrow? Because tomorrow is the 15 marks question. So I'll make sure that when we are answering, okay, term 4 past papers, okay, guys, anything that you want me to focus on tomorrow specifically? We have got the 15 marks question. So someone has just said they want more of the paragraph question. Is fine. I'll help in that regard. Any topic that you feel like this is the most challenging, say, please, when you're explaining this, can you give a comprehensive explanation? Yeah, it's still paper 1. We are doing the final life of paper 1 on Tuesday. So it means tomorrow is still geomorphology, fluvial landforms. No problem. We are going to do that. Yes, of course, I teach grade 10. There's enough material for grade 10. If you can check on my TikTok, I did about 4 or 5 papers. I uploaded a video there. The only one that I'm uploading tomorrow, I think, is for grade 11. That's the one I'm uploading tomorrow for grade 11, the 15 marks question. But there's something that is there. Okay, I teach grade 10. I teach grade 10. Yeah, of course, 10B, I teach grade 10. Guys, of course, people are saying the fluvial landforms. Is there anything specific as well that you want me to focus on? Climate. Of course, go to my YouTube. Go to my YouTube. Nolwande, go to my YouTube. Remember, I'm streaming on both YouTube and TikTok. So go to my YouTube. Okay. Go to my YouTube. Go to my YouTube. Go to my YouTube. Thank you so much, guys. Thank you so much, guys. Please subscribe to my YouTube channel. Subscribe to my YouTube River profile. No problem. We will do that. I'm taking note of what you want. Yes, I record the lives, guys. Go to my YouTube. Everything is there. Go to my YouTube. All the lives that I've done. I was streaming on both TikTok. I'm streaming on both TikTok and YouTube. So you get everything there. You'll get everything there on my YouTube channel. I'm streaming on both YouTube and TikTok. So if you can go to my YouTube channel now, I'm streaming at the same time. Okay. It's YouTube. Check it on my bio. Oh, thank you so much. When you post videos, please stop talking unnecessary stuff. Please just talk about the paper. Thank you so much. Thank you so much. I'll do that. We learn every day. I'm also learning from you. Thank you so much. I'll do that. Thank you so much. I'll do that. I'll do that. I'll work on that. I'll improve on that one. Thank you. That's constructive criticism. I take that. No, it's not. It's not. It's fine. It's fine, guys. You guys are so sensitive, guys. Eh? JBM, you are so sensitive. It's fine. I'm open to anything, guys. I'm open to anything. It's part. It's the package. It's the package of the profession. It's the package of the profession. Thank you, Andy. I'll do that. I'll try to stick. I'll try to stick to the to what is on the paper. Thank you so much. I'll do that as well. I'll do that as well. Don't worry, guys. I take everything, guys. This is how I grow. This is how I grow, guys. I take everything, whatever form of criticism. I take it with both hands. This is what helped me to grow as well. Tap on the screen, guys. We want to get to 20,000 before you go. So you have said that you want river profiles, you want the paragraph question. Okay. All right, guys. It's 15K. Let's get to 20K before you go. Okay, I'm taking note of what you want us to do tomorrow. Okay. Guys, forgive one day, guys. Just forgive him. Just forgive him. Forgive him. No, we should celebrate our differences, guys. We have got people with different personalities. So if you want to do well in life, you should have high level of emotional intelligence. You should have high level of emotional intelligence. You accept everything. You accept everything. Okay. Thank you so much, guys. Let's get to 20K. It's 8:16 now. I know when you're listening, you won't have time to tap the screen. Let's just get to 20K. 20K is 16 now. Thank you so much. I'm just looking at what you want me to do tomorrow. So you've said paragraph question, river profiles. Someone was talking about the fluvial landforms. Tomorrow is paper one. Yeah, it's still geomorphology. Tomorrow, Manelo, we are doing geomorphology, but the 15 marks question now. 15 marks question. You guys, how about the superimposed and antecedent drainage? Superimposed and antecedent? Superimposed and antecedent drainage? Do you know it? Superimposed and antecedent. Superimposed, the base level of erosion, graded and ungraded profiles, all those things, antecedent and superimposed. We'll look at that, guys. Don't worry. Superimposed and antecedent. Obviously, a little bit of river rejuvenation. We'll do that in detail as well. And river capture, we'll do that in detail as well. And also, I'll also try to explain the different courses of the river from the upper, middle, and the lower course. I'll just explain everything detailed, the upper, the middle, and the lower course. What are the dominant processes? What are the fluvial landforms that are formed in each and every course? That is your upper, middle, and the lower course. I'll do that as well tomorrow in detail. I'll also look at the superimposed and the antecedent. I'll do that. How about the drainage patterns? Are you fine with the drainage patterns? Are you fine with the drainage patterns? Are you fine with the drainage density? Are you fine with stream order? Are you fine with stream order? Drainage density, drainage patterns, stream order. Okay, river discharge, your lamina and your turbulent. You're fine with that one as well. Then we have got river and catchment management. Catchment and river management, that one is very easy. River and catchment management, but some of you overlook it. You end up losing marks. River and catchment management, basin management. So we also do that. We are only left with 2K to get to 20K, please. Before we go. Just that I will request. Okay, just that I'll request. Thank you. So that is all, guys. We are 19 now. I want us to get to 20K, then we can call it a night. Thank you so much, guys. I really appreciate. I really appreciate everything. Okay, but please go and subscribe to my YouTube channel, guys. The link is on my bio. Please, the link is on my bio. You can just go and subscribe to my YouTube channel. You are not paying anything. It's just for free. Please go and subscribe to my YouTube channel. The link is on my bio. You just click subscribe. That's all I want from you guys. Everything here is for free. You just subscribe on my link, on my YouTube channel. That's all I want. I'm writing next week. Don't worry. By next week Thursday, you'll be fine. Paper one, you'll be fine. By next week, you'll be fine. So once we are done with our paper one, then we start with paper two. Once we're done with paper one, then we start with paper two. Don't worry. You're writing paper one. By Thursday next week, you'll be fine. You'll be very fine. You'll be very fine. You'll be ready. Thank you so much, guys. We have achieved 20K. So thank you so much, guys. Have a blessed evening. Thank you so much. Have a blessed evening. I'll see you tomorrow, same time. Please, let's try to join as early as possible. Let's also share the TikTok profile with our Classmates, please, let's try to be as early as possible. I'm writing Wednesday paper one. Don't worry, by Wednesday you'll be fine. By Wednesday you'll be fine. Thank you so much. Thank you so much, guys. Bye-bye. Thank you so much.